So now let us take a look at how to interpret the logistic regression model output. I'll just go back to my John prediction Jupyter notebook script. So now I use the stats model package. In stats model, using stat model package, we can get exhaustive information about the logistic regression model summary. Like in our programming language, how we get the summary for the linear regression as well as the logistic regression, somewhat similar to that, we can get it using stats model package. As a first step, I just go and import the stats model package. I just go here. Yes, I already imported the stats model package. First time when I imported it, I was getting some error. The last line of the error, I could see something like centered or something like that. And after that, I did some kind of research. And then when I took this code from the internet and when I executed this code snippet, followed with this, when I tried importing this, it was successful. I was not getting any error at all. So, all right, if you guys face any error at the end of the last line of the error, if you see anything like error, then you try the same way how I tried, right? You can include the same script which I mentioned it above. So now we will see how we can fit a model using the stats models package. So sm.logit function, there is something called logit function. The first argument is your dependent variable and second argument is your independent variable. This is slightly different. So in the xklearn logistic regression class, you need to first specify the independent variable and then you need to specify the dependent variable. It is slightly different. Okay, now you need to use fit. Okay, I did it. And then next one is print logit model dot summary. Good. So we could see an exhaustive output regarding the logistic regression model with the help of stats models. We can get to see a detailed information. Okay, here we can see that the first one, the dependent variable, in this case we have used churn, it's correct, and the model is logit and the method is MLE. The model is fitted using maximum likelihood estimation method. That's what we can see here. And what is the date and time, and also we can see the converge, all the things, and number of observations and pseudo R squared, log likelihood null, and p value. The pseudo R squared value is 0.1528, which is good, which is overall good. And this value ranges between 0 and 1. Any value which is closer to 1, it is good. But this pseudo R squared values, the pseudo R squared is completely different from the linear regression models R squared or address R squared. And how to get this value? So you need to divide this log likelihood value over the log likelihood of null so that you can get, and then you need to subtract this value from 1 so that you will get pseudo R squared. I'll just show you the formula here. The formula is 1 minus natural logarithm of log likelihood of fitted model over natural log of likelihood of null model. You need to subtract this value from 1 in order to get pseudo R squared. So obviously when you divide this value by this one, and then if you subtract this from 1, we will get 0.1528. So now the question is, what exactly log likelihood? What is log likelihood null? You might be asking this question. So log likelihood null is nothing but you fitted a model with all the independent variables, including the intercept. What is the likelihood? Log likelihood. And this one is excluding all the independent variables, but including only the intercept. What is the log likelihood value for this one? It's kind of an empty model. So now if you see here the p value, it is significant. P value is almost 0. P is less than alpha is reject the null hypothesis. Overall, this model is good. And when you look at the coefficients here, it's all in log odds terms. And a few of the coefficients are in positive values, few of the coefficients are negative values. And if you see here, total day calls, you get negative 0.0124 and the p-value is 0.00. So this feature is significant. Including this one in our model will make sense. But how do we interpret this value? Is it similar to linear regression? Partially similar to that, but here it is something like each unit increase in total day calls will decrease the log odds of churn by negative 0.0124. This is how you need to interpret it. Similarly, in this case, total day charge, and even this variable is significant, but here this coefficient value is negative, here it is positive. Each unit increase in total day charge will increase the log odds of churn by 0.0460. This is how we need to interpret. When it comes to international plan and voicemail plan, these two are categorical variable. Since these two variables were categorical variable, we did encoding. And after we did the encoding, we could see 0101 values. Those customers enrolled for or subscribed for international plan, it is flagged with the 1 and encoded with 1, and those did not encoded with 0. Same thing, we did it here. We did the encoding for voicemail plan also. Though we did encoding for these two categorical variables 0101, but still it is a categorical variable. The way how we interpret the categorical variable when it comes to the coefficient value is different from the way how we interpret for the numerical values or the quantitative variables. Here, how do we interpret the international plan? So here, the international plan as yes or no. 1 is yes, 0 is no. Here we cannot interpret a 1 unit increase in the international plan Y or 1 unit increase in international plan 0. It doesn't make any sense. So instead, we need to interpret it this way. Compared to a customer with no international plan, a customer with international plan has 1.9445 log odds of churn, holding all other variables constant. Similarly, in the case of voicemail plan, compared to a customer with no voicemail plan, a customer with voicemail plan has negative 1.58 log odds of churn, holding other variables constant. This is how we need to interpret it. So now the question is, everything is fine, interpreting everything is fine. Now you understood how to do that. But the next question is, how do I convert this log odds ratio into probability? So how do we do this? This we already discussed in the previous session. Can someone tell me? How do we do that? Let's take this one point. How do we convert the probability? First, you need to convert this as a odds ratio. How do you convert the odds ratio? You need to take exp. So in NumPy, we have something called exp function. So 1.9445. So this one, sorry, NP. This is my odds ratio. From log odds ratio, we convert as the odds ratio. Now what I do is I just take this value and divide this odds ratio by this odds ratio value plus 1. This is the one will give us the probability. So now we can say that compared to a customer with no international plan, a customer with international plan has 0.87 probability of churn. The probability of churn is 0.87, holding other variables constant. Okay, so this is how you need to interpret it. Hope you're able to understand now how to interpret the logistic regression model and each of the things I explained you. Next, we will continue with decision tree.